Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Vasilije Markovich about adding memory to LLMs to improve their accuracy. So, Vasilije, can you start by introducing yourself?
Hi, nice to meet you, Tobias, and thanks everyone for listening. I'm Vasilije, originally from Montenegro. I've been in Berlin for around 10 years working in the big data field, worked as a data analyst, data engineer, data project manager, usually managing big data systems, everything from batch to streaming, so pretty close to the data engineering podcast world. And I've been building a memory engine for AI apps and AI agents for the past year. We started as a series of concepts and prototypes based on my studies of clinical psychology and then also combined with data engineering. And we ended up with a Python library that you can build semantic memory on. Happy to share more about that later.
And do you remember how you first got started working in the ML and AI space?
Yes, I was a long time ago working in a crypto company, and they needed to connect the funnels, all the data from the beginning to the end, and see who's who. So I built the first Python scripts, connected all the analytics, and I really liked analytics more than I liked crypto at the time. So I just decided to switch, and then I became a data analyst, data engineer, and then started kind of dabbling all over the ML world, but pretty much stayed within those scopes.
And so, in the context of LLMs, you mentioned that you're working on building a system to add semantic memory to those applications. And I'm wondering if you can just describe a bit about what that term memory means in the context of LLM systems.
That's a great question. So, how I look at memory in context of LLM systems is pretty much based on in-context learning. So, if we have an LLM and we can give it some sentence or two or 10, which we all do when we copy paste some context for it to reason on, we effectively are giving it some memory it can operate on. And this, compared to the traditional, let's say, training and fine tuning methods, is something we can do for almost no money. And now, as things are actually moving along, we're also seeing potentially unlimited context windows where we can create this memory for the LLM. Where this becomes and where we actually start diverging a bit is that we are actually now having to manage this context across a lot of LLM calls. A lot of interactions, and yeah, we see it as pretty much way to manage and structure this in context windows as a new type of some type of feature store. And that's what we call LLM memory in Cognee. But of course, I think the definitions can diverge there.
The opposite of memory is typically considered forgetting, which I know is also a problem in these LLM systems, particularly if you're trying to pack a lot of information into those context windows. And I'm wondering if you can talk to some of the ways that that forgetting manifests as a symptom when you're interacting with these LLMs and trying to build applications on top of them.
Sure. So first, there is the technical limitation, the context window limitation, right? So let's say we have a context window of 4,000 characters that we can put in, then everything outside of that context window won't be retained by the LLM, and we won't be able to reason on that. So we are pretty much technically limited to some ever increasing context, but still somewhat of a limitation for on, let's say, price side and on the other levels too. So that's one thing. The second thing is, let's say we try to change some LLM prompts. So we've seen all these chain of thoughts where we kind of call the LLM multiple times and pass some information along the line. In these cases, the problem is that the most recent information is often enough prioritized compared to the last things or initial things that we gave to the LLM, which can be interpreted as some type of forgetting. Whereas these systems tend to just prioritize what's newer and respond to that, and then the later information, because of the size of the context window and because of the, let's say, issues with the prioritization, can't really get into the place.
Another aspect of LLM systems that adds an additional layer of complexity from the initial playground experience that we have been working our way through over the past couple of years is the idea of going from single turn interactions to multi turn interactions, where you have to have a continual context window and maintain history of the conversation for the LLM to behave in the manner that is desired. And I'm curious how those concepts of memory and forgetting become more complicated, or some of the additional considerations that need to be factored in when thinking about those in the context of these multi-turn systems.
So it again goes to the context. So let's say we have these multi-turn interactions as a set of agents that are working on the same problem, exchanging information. Then it all becomes about the management of their shared context and how we are actually dealing with that. What usually people do, they take these chain of thoughts types of systems as in different LLMs, but effectively it's a sequence of calls to one LLM, which is essentially a single transformer, right? So which has some ins and outs. So you're effectively talking to the same thing with different calls, but if you don't really manage, let's say, the context and the information that's being processed, stored, or managed across these calls, then it's really hard to move forward, right? Because then you're effectively talking to the same system. Although it might seem to you that the system's different, intuitively it's just the same API.
Another piece of that memory equation and the ways that we're managing that in the RAG stack that has been evolving and becoming commonplace in the context of LLM applications is the idea of hierarchical memory. Of there are certain pieces of information that you need to maintain for immediate retrieval given the context of the interaction that's happening right now, but there are other aspects of memory and information that need to be maintained over longer time frames and maybe only infrequently accessed. And I'm wondering what that aspect of hierarchical and evolving memory means in the context of LLMs, and some of the ways that the current application architecture is not up to the task of being able to support those more nuanced elements of memory and retrieval.
Yeah, that's a great question. So when we talk about what is a memory currently for LLMs, we have like maybe let's go back to the basics. We have in context what we copy to the LLM and we say this is your memory. As we said, like it's limited, we forget. So what people started doing is like, okay, I'll just dump everything inside of a vector database. And as everyone knows in the data engineering channel, dumping something somewhere usually doesn't end up well. You know, we've seen all these S3 buckets full of things that have been long forgotten 10 years ago and are slowly mutating to something else. So in this context, the vector store is the same, right? So you're just adding stuff, you're retrieving things based on similarity, but you have no control over what you're getting, the metadata management, the embeddings and indexing. If you change some type of thing, you need to reindex everything, which is slow and expensive. So it feels like we are in the days before, you know, SQL was even a thing in the LLM world, and you know, before relational databases were there. So what we can then do is, and what people do is like, okay, I need bigger memory, I leave it in the vector store. And then we saw that doesn't really lead to some 70% accuracy. Then next step was like, okay, we need to actually map out the knowledge somehow and kind of create some type of a structure. GraphRag is the first, let's say, more serious attempt at that. There were others, and that's, let's say, the direction we are taking as of now. Of course, this will evolve. And then with that, we have an external system. You know, like in the 18th century, you had this nature versus nurture debate. You know, who's going to influence what? Is it going to be the embeddings or is the external context that's going to kind of motivate our thinking and reasoning? In this context, we say both, but we try to outsource this semantic layer outside of the embeddings, so not to actually store everything in the vector store, but actually have a management system outside of it. And that is, in our view, going to allow for this evolving context, because what currently they are mostly is dictionaries with some predefined set of values that are not even data contracts, right? They're just like, you know, a dump of some JSON files that for a particular use case can evolve, and you can add things and then you can forget that. I think that agent paper on Sims agents that forget was pretty much that, right? And although it looked impressive and it showed some capabilities, it simply fails if you really want to do something in production because of all the data issues that we're going to come along with that. So for us, effectively, this is one of the things we're really thinking deeply about. And we're thinking deeply about like, hey, Can we bring the best data engineering practices into this world and like structure the data properly, manage the data properly? Because based on that, we'll get the better output, right? And this is going to allow for this evolutionary nature of the system where we can dynamically overwrite and create nodes and entities. But if we don't solve the data engineering puzzle, we can go to the multi-agent networks and what everyone else is happening to think about. And I'm seeing a lot of talk there, but not much work on the data engineering side, unfortunately.
Another interesting aspect of the way that you presented what you're building right now is this idea of semantic memory, where GraphRag is intended to bring semantics to those contextual embeddings. But I'm wondering if you can talk a little bit more to that aspect of semantic memory as opposed to just a blob of data, and some of the ways that that maps into some of the cognitive science debate and some of the ways that the LLMs are just these stochastic parrots, and the work that's also being done in the space of cognitive AI to try and bring the AI ecosystem into a more nuanced direction versus the brute force approach that has generated the current set of LLM models.
Yeah, sure. So let me give it a stab. So in our understanding, a semantic layer, and we started with let's say creating this type of a semantic layer based on human cognition because we thought that's going to be the best approximation of what LLMs should do. They should think like humans because we have no better reference right now. So we took these data models from Atkinson Shiffrin's 1969 papers on like long-term, short-term memory, episodic semantic, episodic being something that happened to you relatively recently, an episode in life, and semantic representing knowledge of facts like what's an apple, what's a chair, and things like that. So we figured like how about we create these types of memory domains and then we load the data into these memory domains and have them pretty much serve as a semantic memory layer. There was a paper from Princeton last year that pretty much talked about the same thing and proposed the same thing, koala it's called. And we were a bit ahead of them 2 weeks. I think first time I can say that, probably the last time in terms of the academic paper. But what we got to understand is that even by adding and extracting the composition and managing the storage in different levels, we already get improvement in performance compared to the naive LLM calls. And this coupled with a lot of research that's been happening in cognitive sciences and especially research from like 30, 40 years ago that no one's reading in the AI world thinking that's not relevant. We pretty much have a good opportunity now to implement some basic mechanisms like forgetting, attention mechanisms on actually these let's say GraphRag elements. We can quantify and increase the size of the relationships in the nodes and also understand based on the interaction with certain nodes type subgraphs and elements what is important for and what's not. And if we talk about psycholinguistics and we had all these ideas like first in first out, last in first out like 40 years ago, and they've been abandoned these models because we came to like more complex and understand. We took like this neural network approach back to psychology and back and forth, right? But I think a lot of ideas there are still pretty valid, and as algorithms we can start applying them now in terms of how these LLMs should think, and we should have them as tools to see what works, right? And that coupled with a good set of evals is going to get us much closer, considering that things like LLMs are plateauing now in terms of the performance and the outputs, and that's been, let's say, a trend in the last couple of months. So this is our thinking, and we are trying to use a lot of, let's say, traditional approaches there to just kind of push the LLMs a bit forward with a new set of tools they could use. And the koala thing, that model, it failed for us, but it showed us the way that we could kind of do that more. And we then focused on multi-layered networks of language, took some inspiration from these types of approaches, and are kind of currently also investigating a few new things that are going to be announced soon.
And the first era of these large language model applications was very simple. Let's put an API on top of the inference engine and just do whatever goes in, generate some sort of output. Now we're building some more sophisticated architectural patterns, RAG being the most dominant one. So that requires the addition of these vector stores, some sort of re ranking model to figure out which pieces of context we actually want to bring in. And I'm wondering, for the case of bringing in this more nuanced and detail oriented semantic memory layer, what are some of the additional system components, architectural components that are necessary to be able to support that functionality in some of the ways that either supplements or replaces elements of the RAG stack?
Yeah, that's a good question. So if we take the current rack stack, it's, I have a question, then I'm going to like six, seven services that are either chunking, loading, processing, retrieving the data, re-ranking it, and then giving you an output. So already if you have six, seven services, you have a problem, right? Ideally you shouldn't have six, seven. You should have like one to two max. And in our case, what we thought about is like, hey, okay, we can't do all of this work ourselves, right? That's what we see with LangChain, Llama Index, and the others. They're trying to do everything from ingestion, data management, and then graph rag, and then retrieval, and have like across everything across the board. So what our thoughts were, let's create a new type of a data store that is going to be some type of a short-term memory, and that's what we are hearing from the others. Like they want to use Cognee from user interviews, right? They want to use Cognee, a short-term memory store there, have, let's say, something warm that it can retrieve and reduce the number of LLM calls. So ideally we would have something like, hey, we have an ingestion part which is different for every company. They can use off-the-shelf things from Llama Index, LangChain, they can do Haystack, whatever is there. They load the data. We have our ingestion tooling that using DLT supports 30 plus data sources. So, and everything is pretty much done in a way that it can be managed and parallelized and operationalized for production. And then we load the data to this data store, and then we have different types of retrieval patterns, and we pretty much automatically detect and store and process the data in the next iteration. Ideally, we're going to launch this one. And then people can use us in this new stack as a short-term memory, and then they can fine-tune the LLM afterwards and use that as, let's say, a long-term memory, or use that in combination. That's kind of how I'm imagining the stack is going to evolve, because as LLMs get better, as we, let's say, improve the short-term memory, we won't need all these re-rankers, chunkers. They're just going to be a part of, let's say, maybe our system, maybe some other system, but like invisible. You don't need to tweak this manually. And I think avoiding this is going to be a huge thing if we can do it.
And now, digging into Cognee itself, can you describe a bit more about how it's implemented and some of the ways that the initial concepts have shifted and evolved in terms of scope and capability as you've gone through the journey of building it?
Sure. I'll start from how I got started, how it evolved slowly, and then where it's now, because otherwise it's going to be hard to follow, I think. So I started with Cognee after building two failed B2C apps last year. So I realized I have no skills in building B2C apps. I built some food recommender system. I built some image generator app. And as I was doing that with LangChain and other tools that are available, I saw that there is an issue on how to actually manage these contexts. The vector stores weren't giving me back the user's information I was hoping I'm just going to get and enrich on the fly. LLM calls were taking too long. There was a lot of issues. And so I failed with the two apps, and I'm thinking like, hey, well, I know something about data engineering. I've been doing this stuff in psychology, some cognitive science courses, and I'm seeing some patterns I could implement. So I tried posting on Twitter and kind of creating a few prototypes to see, what would people say and could it be used. That led to a lot of activity and success. And I didn't honestly expect that. I had like 38 followers on Twitter or something like that. So it wasn't really something I knew how to do or had those skills. And that led to introduction to one guy, Noam from London, who had a Keepy, a WhatsApp chatbot with around 20,000 active users. And there I had a chance to deploy something to production, right? Because he was looking for a better way to manage the long-term memory, and he needed something better than vector store. Pinecone didn't work for him. He couldn't just make it work, and people were complaining. So first iteration of the product, I took this Atkinson-Shiffrin model of long-term memory, short-term memory, working memory, this Scala paper. I built some Python scripts and wrappers around Neo4j. I vectorized everything with VB8. I built like a combination, let's say some interface for them, and hard-coded these models. This was an ugly piece of code. If you go to my GitHub, you're not gonna appreciate it much. But we deployed it. We deployed it on AWS. It was an endpoint, scalable. We could integrate it with Keepy, and we did. And we saw some activity. People were creating their own, let's say, memory nodes and storing things in the memory and retrieving it. And as we were kind of progressing with that, I saw there is a lot more opportunities, what they called agentic RAG these days, which is like we could create classifiers that could just pick certain types of memories, retrieve certain subgroups of information. And we did that as a second iteration with a tool that was supposed to help architects find the relevant laws in architecture to apply. So if you want to know what is the size of the stairs in an apartment building, we could find the relevant law, extract the information, give that to the LLM, and then just kind of format it. And this worked quite well. And as I was doing that, I saw that the architecture of the tool is not really that ideal. So Boris, my co-founder, joined me at that time, and we were like, okay, we need something more simple, and we need something people can actually use, because people were interested, but they were really having a hard time dealing with our static model and dealing with our code, right? Which is fair. So we refactored everything to become a Python library where we have, let's say, in the beginning, we had three elements. One was add, so you could ingest any type of data from these, let's say, 30 data sources. And on the ingestion, you would have the JSON normalization, merge IDs extracted, all of the fun data engineering stuff that you don't want to think about if you just come from the JavaScript world, or other parts where you haven't really explored that. But we do that for you. We put it all in the meta store. We know and associate all the IDs, and you're pretty much ready, right? Second piece was we did this, what we call Cognify. Cognify is this term that in psychology is used to kind of understand and conceptualize your context. It's effectively how do you understand the things around you and how you put them in your brain. We took that and we called the pipeline Cognify pipeline, and we did a lot of operations, created summaries, created loaded chunks, created some ontologies, a lot of things that ended up with us being able to search for nodes that had certain name, for certain relationships, for embeddings themselves, whatever we needed. And that was, let's say, the first version of the pipeline. As we did that, we realized that our assumption of what Cognify should do is a bit too strong because people need to do different things. So we refactored the library again, and now we have everything in the library being a set of tasks that can become pipelines. Similar to what in the Airflow world you would have with DAGs, we have something like that. So you can inherit from one DAG to another, pass the information, you can chain them together. You can create pipelines that call other pipelines. So all of the fun stuff that would actually let someone use this, we try to implement that, and we try to implement that with generators and then pretty much make it async. We still need to work a bit on parallelization, but effectively the whole process now is we ingest some of the data you give us with external ingestion or DLT. We load the data, manage it. We create summaries, ontologies. You can custom add your tasks. It's just Python functions now. It's very simple. And then we have the search methods, and we have these projections of the graph where we take the whole skeleton of the graph inside of the memory where you can operate on that and deal with that. We raised that last week. And then we plan to kind of build more complex retrieval methods and implement all these default algorithms that are there in the graph field that have been known for a while. And then we'll see where that takes us, right? So that's pretty much that.
And in terms of the data structures and ontologies, I'm wondering if you can talk to some of the ways that you are thinking about how that maps into the, I'm going to use the term conceptual, even though it's a misnomer in the context of LLMs, but how that maps to the conceptual structures that the LLMs are anticipating to be able to help to manage the usage of the context window most efficiently, and in particular some of the ways that you're able to use those data structures and ontologies to map into the problem domain that the application is trying to address.
Yeah, sure. So for us, ontology is a key term here, right? So understanding how do we actually structure and correlate different types of data points inside of one system, especially when we talk about millions of documents coming from, finance, legal, HR. If you just imagine dumping the whole company's data on to something like this, you would expect these types of connections to get formed or to get transformed by the human, which would help the LLM, or work on some type of a preset that it's already given. And we think this is the key piece because there is a lot of context that humans bring into the play, but there is also a lot of context that we can kind of create, and like a lot of ontology that we can generate using deterministic methods, but also using these, let's say, more LLM powered methods. So for us, currently, one of the major goals is to be able to create these ontologies on the fly from the documents by treating each of the Cognee's pipelines as an ML pipeline. So we would do train test sets. That those would be question pairs of different issues, and then we would run the pipeline until it can pass the train, test it on the test set, and that way we assume that the semantic structure and the ontology of the initial data sets would be, let's say, optimal for the question pairs that were given in the question sets. And we could avoid like fine tuning and dealing with that by just using all the tools that are at our disposal to kind of train it. So this is the evolutionary aspect of the pipeline. And this is something that we think is going to become dynamic in the future. So you're going to have dynamic ontologies because as soon as new data comes into the system, like the whole system changed. So you now need to go delete, upsert, like you need to deal with the data in such a way that you can always continuously manage it with while it's interacting with, like, let's say thousands of these agents in the future, because we assume that you're going to have many calls to the LLMs, millions probably in a couple of years, as like the cost is going down already 10x over the past year. It's probably going to go 100x down, and we assume that this is going to be cheaper than the CPU at some point, right? Or at least like pricier, but something that we can afford. So that's where we see it, and that's where we think the context window, as they become unlimited with these bigger ontologies and these subset of ontologies, we can actually get for the problem they're trying to solve. We can then get to a good state of actually making better decisions. So still work in progress, but that's just the general idea.
When dealing with graph systems and ontologies, that brings us into the knowledge graph arena, which has been around for a while. And there has been a lot of tooling built up around it, so I imagine that it's gotten easier to manage. But the creation and curation and evolution of knowledge graphs is, in and of itself, a fairly substantial undertaking. And I'm wondering how you're managing some of that in Cognee without having to surface it all to the end user and add that as an additional conceptual challenge to how they're structuring their overall system.
Yeah, it's a good question. I would say there is like two, three things that would appear to the end user. One is the performance. So if I use Neo4j, I'm going to run into issues, especially at some big scale. So yeah, okay, we need to find something better. So we just did an integration with Falcor DB. We are trying to talk to other people who are building, let's say, these types of databases now, and they are actually popping up. There is some interesting people in San Francisco I met recently, and I think the let's say database stack is going to evolve significantly to support this. I hope we see something in Postgres soon, like PG vector, because that's going to make everything else obsolete. But yeah, effectively, that's one thing. The second thing is like the whole graph management, the interactions and the generations. It's on us, right? So we have adapters for most of the graph databases. We try to abstract everything inside of the system as a data point, which represents a pedantic model that we can just pass through the system and not really be dependent on the different implementation types, but pretty much give the data point or the pedantic model to the adapters, and then have the, let's say, the difficulty of the implementation lying on that side to abstract out these parts of the system. That took a lot of iteration to get to that state. We hope it works. We'll see. But it's not an easy problem. So on that side, how we are solving, let's say, the graph management and iteration is like this. As I mentioned, we project the graph in memory. We are playing with that. We can project n graphs in memory and subsets, and then even do simulations on those. So there is a lot of possibilities that we are kind of introducing into the architecture now that makes us a bit more than an ORM for graphs and vector stores. And secondly, what I think is the key is like who works with you, right? So one of our engineers, he has a PhD just working on graphs. He's been doing that for like 10 years. So he's building and bringing this knowledge, because I'm definitely not a graph expert, and I'm learning from him. I'm running to catch up with the guys. So that's always a good thing to have in a startup. And I think we will definitely see how that evolves. So far, we have a certain set of retrieval strategies, a certain set of ways to generate graphs that we want to implement in the next couple of months. And after that we'll see that my assumption is that we'll have to bring this down to one level lower, so something closer to the metal. But once we get to Cognee being used more in production, then we'll definitely talk about the, let's say, issues that the Python is going to bring us, because it's definitely not going to be the optimal tool for this job down the line.
For people who are interested in incorporating Cognee into their overall system design, I'm wondering if you can talk to some of the steps that are involved in integrating it and taking advantage of it, and in particular, how it might, in the case of a greenfield system, change the way that you want to approach the overall design of the application architecture.
Sure. So integrating it is relatively simple. We have a Python library. We have a Docker image with an API. So you can have everything documented in our GitHub repo. It's open source, so you can just download it yourself. Effectively, the way we deployed it and the way we included it in the system, there is one way which we did, which is ECS. We plan to add SNS, SQS, let's say queue that would just trigger lambdas running Cognee, and we use DCS now for the when we didn't have too much of big loads, and you could pretty much have some S3 buckets sending the events to SNS SQS on AWS, for example, and then triggering lambdas with Cognee. That's relatively simple architecture to do. We also built Helm charts for the deployment in Kubernetes, so you could also deploy it as a service or let's say set of services there. We have this managed meta store. So what you would also need is a Postgres store that you would deploy aside, and that will allow it to actually run parallel instances, and you will be able to kind of trigger it and keep the state, right? So you don't end up redoing the things. And the final place or the final things you would need would be the vector stores and the graph stores. You can deploy these yourselves. We support most of them. So VV8, Quadrant, LansDB. So that's supported. We have Neo4j Falcor now of the graph ones, and NetworkX if you want to experiment with things. And I think like how the architecture would change for anyone who's trying to use Cognee is instead of just having something to load the data from the, let's say, some type of LLM call to vector store, you would add Cognee also as a destination, and then you could just fetch the things from Cognee too. You don't have to do any type of a disruptive modification on your existing system. The idea is like, hey, let's just plug in this memory, get the feedback back. And we have also now evals that are going to be merged very soon, both the LLM as a judge, but also more traditional deterministic ones. And then you can just evaluate the outputs on top of that and see what you get and how good it is. So that's kind of the short version of it.
We touched on the multi-agent systems a little bit earlier, and so for people who are using Cognee, how does that factor into that multi-agent or multi-LLM system architecture, where maybe you have different LLMs that are focused on different problem areas? Maybe you've got a larger model for general language usage. Maybe you've got a code specific model for doing code generation, or you've got an image generation model, and just some of the ways that that impacts the ways that you want to apply Cognee, or how you think about the either segmentation or schematization of the underlying knowledge graph for being able to appropriately retrieve the right semantic constructs for the different LLMs and the different use cases.
So for generating different, let's say, semantic layers, you can use Pydantic. We pretty much allow you to just generate a Pydantic schema that will be represented in the graph in the way you need it. So if you have, let's say, different types of data that you have a custom way of you wanting to represent, you can do it with the Pydantic. We can also help with like having an LLM generated ontology, although I would not recommend that for production. It's going to be dangerous. Secondly, in terms of like the ingestion of the data, we support image, audio, text, so pretty much that's all going to be converted and loaded. Lastly, I would say we have users, right? And these users, they have access to write and read to certain parts of the graph. So let's say you have different microservices. Each of them could be an individual user. If you don't want to really model things, but you just want to keep it isolated, you can still have it all in the same space by just loading to different part of the subgraph that you need. That's shared approach. I think there is many more ways we can isolate this. We thought about like having different graph vector store combinations for different use cases to isolate completely the data down the line. So you could just spin up the instances that effectively then are loading things across just one vertical. But yeah, so far we haven't implemented that. So for now, yeah, the answer is users and the pedantic models you can use to define, and then point towards when you're actually loading the data. But yeah, we are still thinking about this, so any feedback would be appreciated on this side.
Another element to the idea of memory is the use case for personalization for the end user, where you want to be able to store useful pieces of information, semantic context, pieces of data that you have about a user, whether that's their preferences or their demographics, etc. And I know that there are other projects out there. The one in particular that comes to mind is Mem0. And I'm wondering how Cognee relates to some of those use cases, whether you're thinking about some of that personalization aspect or if Cognee is more for managing the data in the underlying problem domain and the data that you would typically put into that RAG stack.
Yeah, that's a good question. So, when I was pitching to investors, by the way, we just secured 1.5 million funding round, which went public today. So, yeah, I don't know when is this going to be shown, but yeah, we just did that. So, I think like one of the base pitches there was like, hey, what's the problem that vector stores and these external data stores are solving that the LLMs can't just do by themselves is the personalization, right? So all of this work that we do is effectively to personalize the data that is fed to the LLMs, so LLMs can give us more nuanced answers to what we need. I think Mem0 and Mem0 and the others like Letta, and there's another couple of let's say projects that are working a lot on like I would call it like almost B2C approach where they let the users or chatbots really have these personalized interactions. We spent time with our first bigger design partner, Dynamo, where we built a support chat system for their human agents for, let's say, gaming industry, where we did the same thing. And the thing is, I don't think you really need a graph rag there because it's not that much data, and it's pretty much just says some classifiers, some extraction of the user personality and like and some prompts. So I think that is not on the, let's say, this user individual response level. It's not a difficult problem. Where it becomes difficult problem is when you're trying to really establish this context across like very complicated domain area, or let's say more complicated set of constraints or business rules that are applied to personalize the data. Because if John is friendly or John is angry, LLM is going to be already pre-trained for that. But if John has a user session defined until midnight, but then every second week it's until midnight 05 because someone in analytics made a mistake 6 years ago when he was defining it, and now the reporting for investors work that way. These types of like more complex cases and managing those and managing those, and also like pretty much text to SQL, right? And all of these, let's say, this context that we could do and build. This is where I think the difference in the approach comes. You're trying to be a bit more general than just focusing on what could give us quick money, but more of like, hey, can we actually build something more sustainable, more long term? Like you're focusing on indexing, right? And indexing for us is personalization. For some others, it's like personalization in really domain of personalization for, let's say, support agents and things like that, which is easier to sell, but I guess it's more difficult to defend long term. So I think these guys, Memo, I've followed them for a while. I've seen what they did with RAG in 3 lines of code. I think they have like really good, let's say, approach to open source, to community building. They are like innovating fast. They're pretty much doing similar things that we do, but the difference is they have their, I think that's my impression, maybe something changed, but they have their code behind some cloud system. They have an API. They will do everything. The magic will be done for you, but I want to be a part of that magic. And I assume the developers in the future want to control how the magic happens, because as soon as we start giving like black boxes, it's hard to trust the black box. And I think that's pretty much the philosophical difference.
And as you continue to iterate on the design and use cases of Cognee and try to navigate the constant shifts in the LLM and AI ecosystem, what are some of the unknowns that you're still navigating?
Oof, so many. I mean, I don't know. Like, I mean, it's a startup, right? So I think everything is unknown except the knowns, which you want to be unknown sometimes because it's bad news, right? So I think in this context, we are facing a lot of questions on what will be the data stack of the future, right? So what will we need to actually use the LLMs in production together with the more traditional systems, and how will these interfaces look like? I think guys like DuckDB and others, they are really doing a good job on kind of moving the needle forward in terms of like what's possible and what can be done. But so far, I'm still not sure where, let's say, the whole stack is going to go. And there's so many interesting things, and things are really rapidly changing, which is not that common in the data world. Usually you can see it like a mile ahead. Something's going to come. But I think now it's a different time. It's actually, it feels like startup time. After like 10 years of like just building slowly the systems. Second thing that we don't know or can't say right now is what the LLMs are going to be like in like 3 5 years. Are they going to, make this whole work unnecessary because they're going to just be so general and good, or not? I don't know. Is RAG going to be even a thing in a couple of years, or are we going to even need it? My core assumption is that people will always need to process data and to ingest it into any type of a system, because I haven't seen a system that works without data so far. And I don't know. Ideally, that's still going to be a need, but if our tool is going to answer that need, I'm not too sure. And then lastly, I think the whole, let's say, research space is super interesting, but super noisy at the same time. So we're reading a lot of papers, we are like checking what people do. And I have people in the team that are much smarter than I am, and have much bigger PhDs from better universities. I have no PhD, by the way, far away. And I think that even they are like, having a hard time distinguishing what makes sense, what doesn't, and they spend time researching for a number of years. And I think this noise plus all the possibilities of we could do, and kind of narrowing down on what we exactly want to do without really clear roadmap is always a difficult thing. But we do have a couple of ideas there. But I think just the space is very large, and you just need to be very strict with yourself. So I think there's always a chance we can make some big mistake there, and kind of go the wrong path. But hopefully that's why we're trying to work with design partners, and more closely with people, so we can solve these problems as they go. So yeah, that's a few things. There is many more operational risks and stuff like that, but I think like I wouldn't go into those too much.
And beyond the core use case and the core focus of Cognee being a tool that aims to improve the overall capabilities of LLM systems, given that you are focused on that data management, data transformation, graph generation, I'm wondering what are some of the other potential applications of Cognee that you either have seen or have tested out, or that you foresee as being capable either now or in the future?
Yeah, that's a good question. I've seen people come, like book a demo and come with say, hey, we have a case in agriculture where, if you plant some seed and there was a pesticide applied 3 weeks before and something else happened, it's a complex rule set. They need a graph for that if they want to have some LLM feature. No, I would never think about agriculture. I come from a village. Like I did run away from that for a reason. Like I would not go back to that. But someone has that type of a problem, and then they recognize that, hey, okay, we could do this with graphs. So we're seeing cases from basic ones from chatbots that's not something too surprising, and personalization of them. We've seen like these cases with architecture. We've seen cases where like construction company that is trying to project on every little brick, some type of a QR code that can get scanned by the workers, so you will know how far the building progress is going. They have an issue that like no building managers want to actually communicate with their system, so they would want to ingest all their data, structure it, load it to their system, so they can update the progress reports on the fly. So very different use cases, very different needs. I think a lot of, let's say, manual work that people have been doing now for like 30 years is going to get automated because they don't want to do it, or there is no really need anymore. And all these verticals that we are seeing, it's super exciting. Logistics, there was a lot of, let's say, movement across those chains, how things move. There was an issue with something like Starbucks menu, right? So that was one interesting case where if you have like a cappuccino or something, it's going to have some ingredients. And then this is like already what ingredients in what proportion go inside of a cappuccino and what these ingredients contain. Then what if you change one ingredient and you want to actually have an LLM suggest you something that has this or that ingredient? You pretty much need some semantics, and you need to update that, the flour changed in some of these recipes because it might have some allergens or something like that. So I think, yeah, we'll see. But so far, I'm pretty positive that there is a lot of use cases where will GraphRag be able to respond to all of those, or some next generation of it, which we hope to kind of evolve towards. Let's see. I think there is already like a good number of things we can do and work
And in your experience of building Cognee, exploring the space, establishing a business around it, and figuring out how it slots into the overarching LLM generative AI ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned?
So where do I start? Don't hire friends in your startup. I'm joking, but like that, that's a good one. You need to abstract yourself emotionally from the business. I think that's one of the biggest lessons I had. I put in all my savings, tried to build this, got now some funding. I think we were also lucky to a degree, right? But effectively, a lot of lessons that are the world works in a certain ways that you don't imagine it when you're working in the data field. And then kind of, when you have reports and analytics and things that are very material to do, the chaos outside and managing that, it becomes somewhat of a difficulty. So I think there was a lot of learnings on the side of the operation of the business, a lot of learnings on assuming things for users. I think like everyone's saying, like talk to users more, but not too many people actually do it. And I think for us, it was like, hey, we tend to have a lot of assumptions and we don't even realize how many. So I think that changed a lot for us. We're now doing user interviews weekly and talking to people, as even if the product is relatively new and not used that much, we are still kind of trying to get as much feedback as we can. And then lastly, I think it's the challenge is often enough the amount, right, of the parallel things going on where you can't really focus and solve one problem optimally. But I think that's also a good, let's say, caveat, because you tend to then solve the problem to a degree it needs to be solved and you don't over optimize. Because I used to spend like 2-3 days solving some, like writing some fancy SQL somewhere to run on some scripts, and it was nice, but now it's like you just choose your battles and you know how to choose them better. So I think that's pretty much on the startup business side. But yeah, I mean it's a broad question, so I'm not sure.
And for people who are building generative AI systems and they're trying to figure out what is the appropriate means of storing and retrieving context for those applications, what are the cases where Cognee is the wrong choice?
Yeah, so if you have something where an LLM call is going to solve most of your issues, or a set of LLM calls, and you don't have much data, you don't need Cognee. You don't need, a complex system just because, well, someone told you graphs are cool. If you have a relatively easy use case where, you're not that worried about accuracy, but you just want to have something generated, you also don't probably need Cognee. If you need structured outputs, you probably don't need Cognee. You can use instructor library or any of these, let's say, tools, so you can get like some data. Where else would you not need it? I think everything that's pretty much agent work right now, you can use it, but also honestly, you probably won't need it unless you have really a lot of agents. So, if you have relatively simple workflows where you can just pass things through in some type of a JSON, I mean, maybe you first get to something working, and then if you want to tweak it, then you can add like a memory layer for it. But if you have 700, yeah, you would need something, but like for more simple use cases. So I would say if you're experimenting, yeah, you can play around with it, but it's probably not going to lead to a lot of results if you don't have much data, or if your use cases are relatively simple, structured outputs can solve them, or you're just kind of trying to do some basic LLM calls. Yeah, you're pretty good on your own.
And as you continue to build and iterate on the core product, the open source project, and just navigate this ecosystem, what are some of the things you have planned for the near to medium term?
That's a good question. So I think so far we are trying to work on continue.dev, which is an open source AI copilot, coding copilot like GitHub has, and we're trying to give it memory. We're trying to use FalcoDB as a new type of a memory, kind of playing with a lot of, let's say, code and how would you call it? Yeah, code graph rag. I think that would be the correct term. And then once we finish with that, our plan is to have these self-improving pipelines that we can just kind of plug into anyone's data and see how they actually evolve. After that, I think we are mainly looking to work with a lot of people in the industry to bring this more to production, work on scaling it, managing it better. And there is going to be a few interesting use cases that we are now discussing with others that I think we can solve. But in the next, let's say, a couple of months, you're going to see better polarization, better support, more scalability, more tests, everything that can make actually an open source software something you want to deploy on your side. And what we will also do is announce a couple of interesting things I still can't talk about due to some contractual issues. But we are trying also to move the needle in terms of the research a bit forward, and some of that's going to be public, some of that won't. But effectively, whatever we do, we'll try to kind of keep the community updated with.
Are there any other aspects of the Cognee project, the overall application of these memory semantics to the LLM application stack, or just the overall problem domain of generative AI applications and moving them into production that we didn't discuss yet that you'd like to cover before we close out the show?
I think this was a pretty good way to cover everything. You did a good job. So I think I couldn't think of anything else at this point. But yeah, I'm happy to talk again in like a year and see where we got with this. But so far, I think this is as far as I can say.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
Yeah. So I think the ChatGPT release left everyone a bit trying to catch up, and everyone saw also that there is a lot of money to be made. I know like guys making 1.5 million ARR with like a teleprompter tool that helps you do interviews, which I'm not using here by the way, but like would be fun if I was. They effectively are monetizing so well that everyone's confused and shocked, especially because these monetization strategies and go to markets have been like really explored over the last decade, and people know what to do if they have product market fit. So the tooling space is rapidly trying to catch up. There is some things that won't change. There was a great post from Yuri Makarov. He's a research scientist in Facebook. I've been also in touch with him a couple of times, and he kind of tried to identify certain areas that are going to stay the same. I think the relational world and those tools are going to pretty much stay as they are, because no one's going to really move from something that works to a fancy new thing just because, and it takes years. In terms of the vector stores, they will probably be replaced, in my opinion, by some open source tools because the technology differentiator is not that big. We'll have frameworks that agent frameworks that actually work. Some of them that exist now work to a degree, but it's still, let's say, debatable on how much can you scale it. Data ingestion and unstructured to structured data, that's a huge use case that appeared last year due to Twitter and people figuring out how can they actually tweak the function calling a bit, which no one was aware of. That's becoming a niche in its own, and I think it's there's a lot of competitors there and making moves. Then we'll see a new players in the database data layer space, where you can have like graphs, you can have vector stores, you can have combinations, you might have something even else. We'll see, but I see a lot of bet on graphs right now. That might change in a year. And then in terms of that stack, we'll have protocols that help us communicate between agent networks. No one's really working on that right now because no one really sees that as a relevant point to monetize on at this stage. I think that's going to come in a year or two. And then we'll probably also have a lot of, let's say, automation on top of the existing tools that will probably have some shared base layer between them, because it's going to just be simpler to use Apache something versus building everything on your own. What that's going to be like, I don't know, but yeah. So I would kind of group it that way. But I would just suggest find Yuri Makarov on Google, and then his posts on the future of the AI stack, and I think he does a pretty good job on identifying what areas can be changed.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on Cognee, helping to shed some light on the overall space of memory and how it is applied in the context of these generative AI systems. It's definitely a very interesting problem domain. It's great to see you working to make that more tractable. So I appreciate all the time and energy you're putting in there, and I hope you enjoy the rest of your day.
Thank you. Thanks for the invite.
Thank you for listening, and don't forget to check out our other shows. The Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.